Welcome to the test review. So the first page here is going to be all the stuff we did last week. So it's going to take a minute. We're going to go back over this, and we're going to take a few minutes to do it in class as well, just to remind you. But the first part is going to be sketching the graphs, filling in the blanks for the following. So we've got an equation, a rational function, and then we've got 4 blanks to fill in: horizontal asymptote, vertical asymptote, domain, and range. Now you have notes on this from last week, but I'm going to try and help you as much as I can here. So a reminder that the general function states that we have a times x minus h plus k, where h means left and right movement, k means up and down movement, and a is going to be vertical stretch and flip. So in these we went kind of easy on you because we have just h and just k. So this x plus 2 is left and right movement. It means that we're going to move 2 units left. So 2 units left means that we're going to have a vertical asymptote at x equals negative 2. Okay? The minus 3 means the graph or the asymptotes are going to move downward. So that's going to be a horizontal asymptote of y equals negative 3. Now, the next thing you want to do is go ahead and graph those. So y equals negative 3. This is the y-axis. So we're going to go to negative 3 and draw an asymptote. Okay? X equals negative 2 means I'm going to go to negative 2 on the x-axis and draw another asymptote. Okay? Then what you're going to do is you're going to graph it. Just generally, I don't need it to be super tight on the points or anything like that, but you need to know that for this graph, it's going to go like this and like this. Okay? And if you need a little bit of help figuring out the actual where the graph is going to be, probably the easiest way to do that is to just plug the original equation into the calculator. So I'm going to plug this one in. 1 over x plus 2 minus 3, and then if you graph it, you should see that your graph does more or less what my graph does. Again, the points aren't going to be perfect, but we know at least which part of the graph the 2 curves are going to be in. Now for domain, it's going to be all real numbers except wherever the asymptote is. So if we're going from left to right, it's from negative infinity to negative 2, and then from negative 2 to infinity, but it doesn't equal negative 2. And the easiest way to show that is to show x is all real numbers, x does not equal negative 2. Range also, bottom to top, and it's going to be the same idea. There's going to be a horizontal asymptote here. That's going to be an exception. So it's going to be y as an element of all real numbers. Y does not equal negative 3. Okay. Same idea for the other one. We're looking here, we have x minus 4. Now that's going to be my vertical asymptote. It's going to be opposite of that. So it'll be x equals positive 4. We have a plus 1, which means my horizontal asymptote is at y equals 1. I'm going to draw my graph. Y equals 1, that's up 1 unit, like this. X minus 4 means I'm going to go right 4 spaces and draw my vertical asymptote here. Again, if I want to be super clear about where my graph goes, I can plug it in just to see which of these 4 parts it's in. Now, the most important part about this is that your curve doesn't touch or cross these dotted lines. That's what they're for. So I'm going to put 1 over x minus 4 plus 1, graph it. Okay, now having these 2, they're going to be in this section and in this opposite section up here. So again, doesn't have to be perfect. I'm going to draw like this and like that. So those are my 2 curves. Okay. For domain, it's going to be all real numbers except for this value. So x is all real numbers. X does not equal 4. My range, y is all real numbers. Y does not equal 1. So just as a reminder, the horizontal asymptote goes to the range, the vertical asymptote goes to the domain. Okay. Now, finding horizontal asymptotes, there's a day that we did this. It's actually very simple, but there are some very easy ways to go through this. What you're looking for basically is what is the biggest exponent on top and the biggest exponent on the bottom. Okay, so what you're looking for here is we have x cubed and x cubed. Those are the biggest. Okay, don't care about the x, don't care about the -1, don't care about anything but those two. And then how you find the asymptote is you divide the coefficients, or the numbers in front. So in this case, because the exponents are the same, they're both cubed, that means we're going to get a number. And that's going to be 4 divided by 8. We're going to reduce that to 1/2. My horizontal asymptote is going to be y equals 1/2. Okay? Next question, same idea. We look for the biggest exponent on top and the biggest exponent on bottom. Well, that would be this. This one is bigger on the bottom, x squared. 2 is a larger exponent than just a regular x. If the bottom one is larger, that means we're going to have an asymptote at y equals 0. Don't even need to do any math. Okay, if the bottom exponent is bigger, that means that the horizontal asymptote is at y equals 0. Actually, that's what this space down here is for. Sorry, it's based on that. And for the last one, we're going to look at the same idea. 3x squared and 7x, those are the largest. Again, we can forget the ones that are smaller. Now, this is bigger on top. X squared is bigger than 7x. If that is the case, if the largest exponent is on top, that means that there is going to be no horizontal asymptote. So these are your three options. It's either going to be a number if the exponents are the same, it's going to be 0 if the bottom has a larger exponent, or it's going to be none if the top has a larger exponent. And I'll try and make sure I have a note on the board for that so you can remember, because it is something we haven't done for a while and it only really comes in handy in this time. Next, we're going to go ahead and factor the following polynomials. This is super important for everything that we've done over the last week, obviously, but just to remind you, we have 3x squared plus 9x. Now in this case, we have an a and a b, but there's no c. Okay, so you don't need to use the x to factor this one. What you do need to do is find the GCF. So look, we have 3x squared and 9x. Well, they both have at least an x, but they're also divisible by 3. So we're going to divide them both by 3x. So the 3x will then go on the outside of some parentheses. 3 divided by 3 cancels. X squared divided by x leaves me with an x. 9x divided by 3x gives me plus 3. Okay. Next one. Here we have an a and a c. Okay. But they also have a common factor of 2. So we need to make sure that we divide everything by 2. Okay. And then we're going to take that out. This becomes 2 times x squared. Negative 72 divided by 2 is 36. This inside can still be factored. So we're going to use the ABC trick for that. A is 1, B is 0, C is negative 36. And then we're going to find the factors that multiply to negative 36 and add up to 0. As a reminder on the calculator, to do this, you're going to take the top number, negative 36, divided by x. Below that, negative 36 divided by x plus x. Go to your table, you're going to look for the bottom number on the far right hand side, and I see it right now. It's 6 and negative 6. Then we divide by our value for a, and that's going to create 2 new factors. So here, this is going to become, I'm sorry, I'm running out of room at the bottom. The 2 comes out to the front. 6 over 1 becomes x plus 6. Negative 6 over 1 becomes x minus 6. So those are my 2 factors there. On the last one, it's just a regular old factoring, okay? So this, we're going to start off with a, b, and c because we have all those values. A is 1, b is negative 7, and c is negative 18. On top is a times c, or 1 times negative 18. On the bottom is going to be b. So to find these numbers, I'm going to go in here. I'm going to put negative 18 in, divided by x, and then negative 18 divided by x plus x. And I'm going to look for negative 7 on the far right hand side, and sure enough, there it is at the top. 2 and negative 9. So I have 2 and negative 9. I'm going to divide these each by 1. 2 2 over 1, negative 9 over 1. This becomes x plus 2 and x minus 9. And that's page 1.